equations, 3 variables, huh? 3 equations, 3 variables. And then, unfortunately, this is not a store problem either. You know, which value is not a solution? All right, I got to actually figure out what the solutions are and pick the one that's not. All right, I can't do a store here. I wish I could, but all right, here we go. 3 equations, 3 variables. I started off by picking 2 out of the 3 equations to write down. All right, so everyone, I got 3 equations, 1, 2, and 3. I make a decision. Pick 2 equations so that at least one of the variables are going to eliminate each other. So I'm going to leave that up to you guys. I'm going to leave that up to you. Anybody have any equations you want to pick in particular? Go ahead, Aaron.
The X, or the second one and the third one?
Second one and the third one. So that'll eliminate Z, right?
Yeah.
Anything? I don't think it'll eliminate anything else, right? Okay, keep looking though. Here's why I'm going to say keep looking. There are 2 equations I could pick where actually 2 variables get eliminated at the same time. And that's better than having 1 eliminated. Anybody see 2 equations I could pick that actually 2 variables get eliminated? Nora?
1 and 2.
1 and 2. So let's start with 1 and 2 just because I can eliminate 2 variables. So x plus y plus z equals 9. X minus y minus z equals -1. And also I highly recommend, you guys remember these last year? It took like a whole page to do these problems, right? Number your steps, all right? Number your steps so we know when we're correcting it. Okay, they're going from here to here to here. All right, can you guys combine everything you can? First question for somebody, what cancels here? 1, what's going to cancel here, Amanda? Yep. Anything else? Are they both have the same sign? Okay. What about the Z's? What's the sign on this Z? And this one? So what's going to happen?
Oh, they will cancel.
They will cancel. So that's why I said pick those 2. You're going to eliminate 2 variables. I made this mistake. I don't know if you guys are. How many X's do you have left? All right, don't write X equals 2X, right? Because you have 2 of them, so you got to add them together. 2X equals, what do I have on this side? 8, and I think you guys are good, right? You know the value of X now?
Well, wouldn't you divide it by 2 or no?
Oh, yeah. Go ahead. That's what I'm saying.
Yeah, divide by 2.
I don't think I have to tell you, right? X equals 4, so we know the answer is not going to be choice 4 because we're looking for what's not a solution. All right, now what do I do after I pick 2 equations? Pick 2 other equations now. All right, pick 2 other equations where I can eliminate a variable. But don't pick 1 and 2 again.
2 and 3.
You want to pick 2 and 3 now? I'll get back to that. I'll show you some love there. Okay, so equations 2 and 3. So I'm going to pick 2 new equations where I can eliminate a variable. Oh, what variable gets eliminated here? 8. Sorry, no, where are you at?
Z.
Z's are gone. Good job. All right, what am I left with now? Combine your like terms. Combine your like terms. What am I left with? 7. What am I left with here? X and X? No 7. Tim, that's you.
2x minus
2x
2y
minus 2y
equals 20.
equals 20. Wait.
And
Oh,
we need
no. Can I go a little further here?
we need
Huh?
x is equal.
Don't I know that value?
Yes.
What's x equal to? Plug it in. Now it becomes what? Not 2x, but 8. We already knew the value of x is 4. Plug it in. That's 8 now. And now what can I do now? Which variable do you now can find the solution for? Y. Yeah, there you go. All right, so we didn't have to be nervous with the 2 variables because I already knew the value of one of them. So I plugged it in. Now I can find y. So when you get to that point, let me know. Let me know. Take your time. What's the value of y when you get to it? 4 when you're ready. -6. So there goes choice 2, right? All right, once you know 2 out of the 3, you don't need to pick 2 more equations. Why? If I know x and I know y, how am I going to get to z?
Plug it in.
Go back to the original 3, and Aaron,
Plug it in.
plug it in. Go back to the original 3, take one of them, plug in 4 and -6, and we'll get our z value out. So once I have 2 variables, no need to pick any more equations. Plug it back in. Whatever you think is the easiest. And when you're ready, what is that value of z? 3 when you're ready. Yep. So there goes choice 3. So the only one that's not a solution is -8. We will be definitely going over more of those because they do get more complicated. This one, it's pretty rare that 2 variables get taken out at the same time. Usually it's just 1. So we'll have to go over what happens when I can only eliminate 1. Any issues here? Aaron, sure, hurry it up. I'm going to keep going here. All right, 21, everyone, 21. All right, what's the solution to those 2 being equal to each other? All right, before we go nuts here, I get it. Probably, what are you guys going to do? You're going to take, let's say, choice 1, -3.6. What are you going to do with it? Plug it in for f of x, plug it in for g of x, see if they're equal to each other. If it is, I got my solution. That's probably what I would expect you to do, and I want you to do, with a little catch. And I'm apologizing. I'm sorry. I'm throwing so much at you when it comes to this device. Where's this button? Where's this button? I get it. But there's one little thing you do definitely have to be aware of. See how this has sign in it? Anytime you plug a number into an equation that's got sine or cosine, hit your mode button. Hit your mode button. Anytime you plug a number into sine or cosine equation, it's got to make sure it's in radian mode. Okay? It's got to make sure it's in radian mode. That's the that's the only time your calculator's got to be in radian mode. I prefer it to be in degree mode the rest of the time. This is the only time you need to change it over, is when, if, I'm not saying you're going to have to, if you plug a number into sine or cosine equation. All right, it's got to be in radian. I prefer it to be degree after we're done with this problem. All right, go ahead. Start plugging in your numbers now. -3.6, does that give you the same value? -2.1, -1.8, and so on. Because you're looking for where they're equal. So what value there makes them equal to each other? And there's one last wrinkle to this problem, because you guys might be confused or just plain unhappy at the end of this. Are you guys getting through all 4 and you didn't find any? Is that the problem we're having? We didn't find any that equal each other?
Yeah.
Not we mean not yet.
No, I said yeah, but I don't know if that's correct.
Okay, here's the thing though. Notice, ready? Read the first part of the question. For which value to the nearest tenth. So they rounded their answers already, but you guys should be getting, out of those four, one of those answers should come pretty darn close to each other to being equal. A lot closer than the other three. Our solution here is going to be the one that comes the closest to being equal to each other. And one comes pretty darn close to being equal versus all the other three. No. That's embarrassing. See that one? When I stored in 1.4, I got 0.932 and I got 0.944 here. That's the closest as any of those other choices come. All right, so everyone see? And again, why doesn't it come out to be exact? Because the problem was already rounded. That's why they're not going to be exact. Are we okay on why it's going to be choice 4 versus maybe some of you maybe choice 2? That was like what, 3 point something to 4? That's not close as 4 was. All right, not even as close. Talk to me here. We all right why I'm circling 4 and how I get this answer? No, Catherine? Are you okay? First, are we taking like negative 3.6, plugging it in here and here? That's it. Okay, I don't even get an answer that's close to being equal to each other. So now I do the same thing with negative 2.1, and I actually think I wrote that one down. That gave me negative 3.6 on this side and negative 4.061. Pretty close, but not as close as this one gave me. Because
it was negative 3.6 because that's what I got, and I didn't do the other side.
Okay, well, that's what the other side would have given you, negative 4.061. Close, I agree, close, but definitely not as close as those two. Okay, Dylan.
Is it possible you could like graph it and like see the intersection, or is that something?
You could. Again, and I don't want to say this because we don't need a graph to do sine cosine, but if you did graph it, you do need to be in radian mode as well. Anytime you graph sine or cosine, needs to be in radians. Okay? All right, can you go back, change it to back to degree mode for me? All right, change it back. Again, that's the only time you need it in radian mode. All right, I got 2 more problems here with you, and then you're on your own. Jared, here you go. 26. Going back to your remainder question. Show me why x minus 3 is a factor of that. And I get it. I know how you guys have been trained. Don't do this, though. Watch me do this. I know most of you would go, you know what? I'm going to try to factor this. And I see 4 terms. I'm going to group it. So you go, dun, 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 I'm going to group, take an x squared out. I'm left with x minus 1. And then you get to that one. And what are you going to do? Not taking anything out. And you know if you're going to group, what's inside here has to match, and there's no way. So there's no way you can group this to show that x minus 3 is a factor. How do I show it's a factor? I do synthetic division. And if it is a factor, I get a remainder of 0 at the end of this. All right? If anything is a factor, you should get a remainder of 0. Remainder of 0. So let's see if we do. From our talk last problem, what's going to go in the corner box? 8? 3? What are the numbers along the way here? 6?
1.
Yep.
1.
Oh, 1?
Or negative.
Good. Negative 1. What else, Ryan? Let's roll.
Negative 5.
Got it. If it's a factor, I should get a remainder of 0. Oh, everyone stop. Pencils down. I'll get back in a second. What if I do this? Say that's never there. Is it just going to be 1, negative 5, and negative 3 across?
No.
Do you remember last year? Every single exponent needs to be represented. You see I don't have a square here? So instead I'd plug in a 0. Okay, so if you need to fill something in that's not there, see I got 3, 1, 0, but I don't have an exponent of a 2. I got to put a 0 in its place. Okay, so remember, I got to put a 0 in its place if nothing's there. All right, help me synthetically divide this. Hopefully we get a remainder of 0. What am I dropping down? Drop the 1 down. 1 times 3 gives me 3. What's my new number down below? 2.
6.
6. Negative 5 plus 6. 1. And then what?
0.
Well, I get 1 times 3 gives me 3. Hey! We get a remainder of 0. So that means it's a factor. Okay? So justify your answer. Show why it's a factor. Remainder was 0. So that's awesome. We did 2 synthetic division problems here today. Whoa, whoa, whoa. I'm still going to challenge you. What's the answer to this? When I do divide them, what is the answer? How would you write your answer? You ready, Jared?
I think I am.
Go.
M of x equals x squared plus 2x.
Oh, don't just leave out the m of x. X squared.
Plus 2x plus 1.
There you go. That's the answer when I divide them. No remainder. Jake.
How do you get the 3 in the corner, Jim?
Opposite of whatever you're dividing by. Okay? If I go x plus 5, there's a negative 5 there. Okay? You good? You're awake today? All right. Need me to drop kick you to wake you up? I got a good one in me. I got the new hip. I'm ready to roll. Test it out. 28. Last one. Oh, boy. Oh, good times last year, huh? These words mean anything here? Focus. Directrix. Oh, boy. Can you please get the sheet out that has the list of formulas you're not allowed to have? And I believe it's under number 10. Parabola. First thing here, it's not a typo. I just want to make sure we're clear. See this P here? That should be down with the 4. So make sure it's 1 over 4P for me. That P should be down in the denominator. 1 over 4P. Please. Okay, so keep that with you right there because I'm going to reference this in a second. All right, make sure the P is down in the denominator, 1 over 4P. All right, real quick. Last period knew a little something about this. Let's see if you guys do. Vertex. Anybody remember where it's located as far as the directrix and the focus go? I know the directrix. I know the focus. Where was there always vertex? Vertex was always. I don't know what this.
So it's like the vertex would be in the middle, and then
half
the 2.
The middle.
The middle.
Thank you. We're good. The middle. Vertex is. I feel like you're getting salty too with me, Jared. Is that possible?
No,
Throwing a little.
never.
He's getting a little attitude. You've seen it. Vertex is halfway between focus and directrix. That's how all these 3 line up. Directrix, vertex, focus. And the vertex is halfway. So watch, and I don't expect you to draw this. You can if you want. Directrix, that was always a line, right? That was a line, the directrix. And I haven't even gotten to this problem yet. There's your directrix. Here's your focus down here. Now, where would the vertex line up? Halfway. That's the lineup of these 3 points. All right, that's the lineup. Vertex is halfway. Also, just another piece of info here. Anybody know how this problem is going to go? Smile or frown? If I drew it in? The curves, smile, or is it going to frown? Anybody remember? Why?
Because there's a negative.
Oh, good. Because there's a negative out in front. Also, never crosses the directrix. Okay, never crosses the directrix, the parabola. Always goes the opposite way. So here's what I would like you to do right now. Make an XY graph. I'll walk around watching you and just graph the focus for me. Graph the focus. Do an XY graph for me and graph the focus. All right, everyone's got a graph. And what's the problem asking me for, by the way? I got to find the what? Of the remaining two, which one am I responsible for? Directrix. All right, where's the directrix? So that would be, whoa. So if you're going to have me find the directrix, I should know what's the last point. I know what the focus is. I need to find the directrix. I should be able to find the what then? Yeah, where's the vertex then? I don't see anything that says this is the vertex. You don't, because you got to use the equation. The equation has the vertex in it. Look at your sheet again. Look at your sheet. See how it says x minus h squared plus k? H and k, whatever numbers are plugged in there, that's your vertex. The equation has the vertex built into it. All right, so look at the problem we're doing right now in the Regents. What numbers plugged in for h and k? Because that's the vertex. What numbers are plugged in for h and k right now? What's the vertex using that? The 20 has nothing to do with it. Think you got it, Jake?
3 and 6.
3 and 6. 3, 6 is plugged in there. The equation comes with the vertex. So everyone graph 3, 6.
Positive 3.
Yes. Because watch, this is why, Clayton, it's x minus h, right? You see how it's already x minus. Now, whoa. I throw a plus there. Now it's negative 3, 6. Okay, it's always the opposite of what's inside. All right, good question. So everyone graph 3, 6, 2, 3, 4, 5, 6. Here's the vertex, halfway in between. Can you guys find where the directrix is going to be now? The vertex is halfway in between. So you got to go on the other side. So now I look, ready? How far apart are these two?
5.
5 units. So now I go 5 units this way. 1, 2, 3. I did it again. Ran off the graph. Right? 5 and 5. Vertex has to be in the middle. But the directrix, remember, is a line, not a point. I don't want a point here. Directrix is a line. So what's the equation of that line right there? There's my directrix. What's the equation of that line? Because that's going to be my final answer. Where does it go through?
X equals 11.
Not x equals.
Y equals
Y equals 11. Any horizontal line here, y equals 11. Everyone all right? Why it's 11? Here's 1 to 5 is 6. Go up another 5. 6 plus 5 is 11. And it's not a point, it's an actual equation here. Y equals 11.
And it's always dotted lines.
Doesn't have to be.
Oh.
I just like to show it that way. It makes it different than my axes, Jared. That's why. It's a teaching tool I like to use. That's what they told me in teaching school. Questions? All right, here you go. Tomorrow, August 2019. It's got to be here, all right? August 2019 in class. Here are the 3 I want you to try now and into tonight. I'm asking 3. I could ask for, hey, everyone do it the whole part 1. I'm not asking that. All right, we do the majority of the work here, but you got to do some stuff on your own. 23, 32, and 36 from this exam. And then we will start August 2019 tomorrow.
Yeah, 3,11.
And my availability the rest of the week is completely open. 2, 5, 6 after school. Completely open.
It's just
I'll stay after school.
the 3 is.
I'll be here, whether you're here or not. So. I don't even know what time we get out now.
11:03.
What's that?
11:03.
Oh, wow, look at that. 2 weeks from Thursday.